Hello everyone and welcome back to my channel. In this video we are going to be talking about the SQL select statement. If you have not subscribed to my channel, please do subscribe. Now let's jump right in. In the last video we talked about the select statement where we had, for example, select star meaning everything from a table. So you have select star from. And we said if you have your table in a schema, the table name would be the schema name dot the actual table name. So for example, from our bank schema, we have bank dot account. So this would be selecting everything from our bank dot account table. But supposing we wanted to know only the names of people who own accounts in this bank, we could just say owner. We just want only the owner column. So these are the only people who own accounts. It's also possible that when we return this resultant table, we want to call it something different, maybe account name, right? So I'll just introduce something else now called aliasing. So in SQLs, we have something called aliasing. One of the use cases would be to change the table name, column name actually, of a resultant table, right? So we have, let's say I want this to be called account names now. So I have, these are the account names in this bank. So you see, it's called account names now. I want us to look at this slide. So I had mentioned that in the SQL select statement, you have select column list. It could be everything where we use that. It could be one column, it could be two columns. And where we have two columns, we could just use a comma to specify the rest, right? So we have select column list from some table. Then the where is where we put in the conditions and the relationship between the two tables. Let's take an example of a situation where we have table list after the from keyword. Look at this query in English. We have, it says, show me the account number, account balance, and deposit information for all deposits to accounts having more than $1,000. Now let's look at our table. If you can remember, we created these tables in our last video. We know that account owner and account balance are all in the, let's see, they are all in the account table. So we have the columns here, and under the columns we have, this is the account owner, right? And this is the account balance. But we do not have deposit amount in the account table. So this means we are going to be selecting our columns from a list of tables now. So let's try to translate this SQL. This is not SQL. Let's try to translate this query written in English to SQL. So as always, we start with our select. So we want to select owner, and so now we have list of columns as well, and balance. And these two columns come from bank.account. We also want to select deposit amount. And as we can see, the deposit amount is in our deposits account table. So this is a deposit amount. So we also want to select bank.deposit amount, right? And from there, we want to select I have made a mistake. We want to select deposit amount. This is actually deposit account, not amount. The table name is called account. Or yeah. So this is deposit account table, and we have the deposit amount column. I just wanted to make that clear. So before we specify what we would have in our where clause, let us talk about these columns and the tables. I already gave an instance where we use the alias, right? The next instance I want to give is also a use of the alias. But this second use case is because it's possible to have different table names having the same column names. For example, it's possible to have deposit amount, balance owner in deposit in account table, and also have owner as a column name, balance as column name, deposit amount as column name in the deposit account table. So because this is possible, we also use an alias in this case to tie each column name to their respective table, right? So without using an alias for this use case, we would be saying bank.account.owner, bank.account.balance, bank.deposit account.deposit amount. That is a lot of words. So instead of saying that, we use an alias. And usually it suffices to write whatever you want to use as an alias just beside the name of the table. So we have bank.account A. So that means it's like saying bank.account table will also be called table A, right? So because the owner column is in account table, we have a.owner. So this is how we use this alias in this use case. When we want to tie or want to show that a particular column is from a particular table, we use the table alias or the table name dot the column name. So you have a dot. So here you would have d dot this. Right. So because we are dealing with two different tables, an important question I want you to always ask yourself when you're drawing information from two tables, because that at this point has become an implicit join. It's called an implicit join because you are drawing information from two different tables without using the keyword join. But in as much as we are not using the keyword join, it's a kind of join and it's called an implicit join. So the first question I want you to ask yourself is, between the two tables or between the tables you're drawing information from, are they related in some kind of way? In the last video we talked about primary keys and the relationship to foreign keys. And this is what I want you to look out for. Are these tables related by primary keys, foreign keys? And in this case, yes. In the account table, we have the account number, which we said in the last video where we created these keyman tables. We said that the account number, that's the number column, is a primary key. And then in the deposit account table, we also have, as you can see, a column called account number, which references the number column in the account table. So because we have this relationship, we are going to write our implicit join. So we have our A in the account table. We have the number column, which is the primary key, and it is referenced in the deposit account table, represented as D, right? It references the account number column. So showing this, we have just done an implicit join. It's called an implicit join, as you can see right here on the slide. It's called an implicit join. All right, so showing after writing that, the last part of this query in English says that we want to show this table for accounts that have more than 1,000. So for accounts that have more than 1,000, let's This is where we use an and we want balance, and balance is in the accounts table. So you have a dot balance more than 1000, so that's greater than 1000. So there's one thing I would want you to notice though. One thing I want you to notice is that let's just execute this query. So this is what we have. The first thing I want you to notice is that my money is in parentheses, and it's in parentheses because it's of the data type money. The domain is money. If we had defined this column in the domain integer, this wouldn't be in parentheses. This wouldn't be in quotation marks, actually quotation. I just wanted to mention that. Why am I saying parentheses? Okay. Okay. So um so we've talked about implicit join at this point. The next thing I want us to talk about is cross product. And if you're familiar with linear algebra, that should sound really familiar. And whatever you think about it, if you have experience with linear algebra, you're right. It's the same concept. So what specifying the relationship between the tables with respect to primary keys, foreign keys, and bringing them together in this way, showing an implicit join, what it does for us is that it removes the possibility of a resultant table being a cross product. Let me show you how cross product behaves. So without this statement here, the resultant table would be a cross product. Now, what is cross product? So what our cross product would be is the set of values from the first table, that's the table A, would be mapped to each value from the D table until it has mapped completely, one by one, every value in the D table. So that would mean, since we have 8 rows, right, or 8 records, if this was a cross product, we would have 64 rows. That's because the owners and their balances from Alice to Henry, for each set of 8 of these 8 names, it will be mapped. The first 8 will be mapped to 1000, second 8 will be mapped to 2005, third 8 8 will be mapped to 500, just like that. Let me show you this behavior in it right now. So once we remove this and we run this again, you see now that we have 64 tables. Let me expand this a little bit. So you have from Alice down to Henry. This is the first set, all right? Everything is mapped to 1000. Then it repeats itself again. Then it's mapped to 2500. Then it repeats itself again. It's mapped to 500. It continues that way until it maps everything from the first table to the last value from the second table. Now, I don't know, maybe this would be a use case for you. I'm not so sure. But we prevent this by specifying our implicit join, by simply showing the relationship, joining implicitly these tables based at the point of their relationship. So we have talked about cross products and we have talked about implicit tables. The next thing, and I think the last thing I would mention in this video, is that the resultant table you get from every query, the resultant, record you get from every query is a table. But the moment you run on that query, that table is deleted forever. Right? That table is deleted forever. So if you, for any reason, you want to save the table that you have just gotten as your result, you can use the into keyword. So we have another keyword called the into. You simply say, you write your select statement as you would write it. But then just before the from keyword, you have an into. Now I want to store it in the bank schema and I want to call this new table. Let's call it results one. Results one. And you see that when I run this, it's automatically saved. Let's see. So I just have to refresh these tables. So let me refresh my bank schema. Yeah, I've refreshed my bank schema, and now you see I have 4 tables. I have 4 tables. So I have all the tables I had and results 1. And if we wanted to view results 1, we'd just say select everything from result 1, and this is it. Select, oh yeah, I needed to specify the schema from bank.result1. Right. But because I have no need for this table anyways, so I will just delete it. So that will be drop table bank.result1. So we're going to run that. It's successful, and yeah, we're going to end this video at this point. I think we've covered a lot, and you'd also need to practice on your own by yourself. Please do practice. Hopefully you've gotten um, the spy data, the spy schema and its table. That's what I meant by spy data. And if you have, um, in the next video, we are going to do more about implicit joins and explicit joins, as the case may be. So I think I'll just meet you at the next one. Subscribe to my channel. I'll see you on the next video. Bye.